Got a couple things to get to here. Got to finish up last little bit with objects and classes. Sorry to miss you Wednesday here. We can talk about the final project, right? And then we got to get to pointers. We don't have to go super deep on pointers because this will be a major topic for you next semester. We just kind of want to introduce what a pointer is, some of the basic things we do with it, and then you'll have all sorts of fun with pointers later here. But we got to hit some of those highlights. This should be pretty good. So for Zybooks, we'll have chapter 9 do probably 12-1 because we'll pretend the week of Thanksgiving doesn't exist. So take the whole week off if you want, work ahead if you want, whatever you want to do. But I'll plug that in for 12-1 for chapter 9 here. And that'll be the last Zybooks chapter. You all excited? Very okay. I mean, in terms of it being a textbook, how does it compare to like other actual textbooks that you have?
Uh, Use it more.
You use it more?
Use it a lot more than textbooks.
Okay.
I don't buy the textbooks.
Oh yeah, yeah, yeah. Sometimes you can get away without buying textbooks. Yeah, I know how that goes. Um, no submission, sweet. And then a reminder, we do use the rest of this for CIS 200. Most everyone, as far as I understand, doesn't give you points for doing it anymore in 200, and there's no labs. So you'll want to go through and print every chapter to PDF so you don't have to go buy it again. Because that would be dumb to have to go spend money again here. So, but you can't print the entire book, but you can print one chapter at a time. Sure, it takes a couple steps, but it's not too bad. And then all of the cool interactive stuff isn't there, which is a little bit sad. You can't do any more, like you don't have access to the website anymore, but you've got all the content there. Oh, did I not mark this as okay? Don't worry, I didn't mark these as optional. Sorry for exceptions and stuff. But whoa, oh thanks, all my notes. That why are you just loading now? My computer's being crazy here. Um, but we'll finish up this one here. We didn't get to separate files yet, right? And then we want to get to unit testing, some of the constructor overloading. Some cool stuff here, operator overloading. You'll pick up this again in 200. You'll do more operator overloading. I just want to show you what it looks like. Um, and then static is a big topic as well. Wow, my computer's having fun. I should close my phone though, right? We don't want that. All right. And then we'll get to our pointers exercises here. There's a lot to pointers. Again, we're just going to kind of we'll breeze through most of it here, but we won't do a whole lot with it. Okay, so we'll play a little bit with them, and you can kind of see what they do, which would be kind of fun. Let's see. So objects and classes. Yep. So you'll get to inheritance later. We're supposed to talk about recursion at some point because that is one of the items on our list, right? I think there's an item in our list here that you can write recursive procedure. We don't need to go over the whole chapter for recursion, but I'll talk about that in our review week. We'll pick up that last topic, and then the UML stuff that we haven't got to yet either. There's no chapter for that. It's drawing a picture. If you can write code, I assume you can draw a picture, but there's a correct format to use for drawing this picture so that if everyone draws it the same way, we can all read it the same way, and life is good for all of us. So it's a good tool for communicating when we're designing software, which is a lot of fun. All right, and I think that about gets us through the class. We are aiming to be done by Thanksgiving, essentially, with just last couple miscellaneous topics after that. And we'll talk about the final project. Um, we'll do presentations. You're welcome to work with a partner on the final project. You'll do the same thing whether or not you work by yourself or work with a partner, because it's actually more work to have to coordinate with someone and then make sure everything works and like they don't screw up your code and you don't screw up their code. And um, so if you want to work with a partner, great. If you want to do it individually, that's cool too. Yeah.
Global partner won't be under like have one repository only of that person's name or both are separate and then submit the same code to you.
So I can set up a shared repository that you both have access to, and you can both commit and pull and push to it, or you could do it separate. You could send files to each other. You can use Google Drive. I would recommend you use Git, but again, it's totally up to you, however you want to go about it here. Yeah, but if you'd like the shared repository, that's easy enough. I can just add one of you to your partner's repository. So you can both commit and push to it. All right, somebody's fire up Visual Studio. Anybody go to Comic Con this weekend? No? Aren't you a bunch of nerds? No? Okay. Kind of. It's just down the street from my house, so it's not bad.
Pick up snow that I got from there.
Yes, yes, I did. I almost stole it apparently, and one of the vendors like wasn't angry at me, but I they were like a booth, and they were next to the booth, and I thought it was for this booth, so I took it over to that booth, and the guy like chased me over. It's like, oh, it's like right in front of this booth. I'm sorry. It's like, no, it's okay. I just want to make sure you're gonna buy it. It's fine. That's good. They're looking out for each other because some people are crazy. But yeah, I was really excited. He's my favorite Pokemon. So, all right. So we had a couple classes here for vehicle. We had chair, and we had lotto ticket. Right. So we did a couple. Nothing super interesting with these, but um, the piece that we got to is, does it do what it's supposed to do? And the only way we were able to figure that out is by putting a bunch of code here and running it, and then looking at our output and seeing, does it look like what I expect it to look like? Right? This idea, software shouldn't be this sort of black box that stuff goes in, something magical happens, and something comes out. Right? We need to understand that process in the middle here. Um, Forget large language models, pretend they don't exist for now, but we need to understand what code is doing so that we know if this goes in, this is what comes out. Right? It should be a predictable process. So if we understand it well enough to write the code to do it, we understand it well enough to say, okay, I put 7 in, I get 22 out. Sure. And whatever our stuff happens to be here, we can go do that here. So I get one lotto ticket and I get another lotto ticket. This one wins. I get this lotto ticket and a different set of numbers. This one loses. Right? That sort of code I need to be able to test here. Now, it turns out, have you guys ever written an English paper? Are you good at proofreading your own papers? No, because we know what it's supposed to say. So it's really easy to just miss when it doesn't say what it's supposed to say because we think it says what it's supposed to say. And we're not actually fully reading it. I don't know if that makes a whole lot of sense. But the same thing happens with our code. If I run my code and I look at the output, I know it's supposed to come out. And the chances of me not reading the output correctly and be like, oh yeah, that's good, that's pretty likely, right? Can we be honest? We're likely to screw that up. So, you know who's really good at taking an expected result and comparing it to what actually came out? Who's really good at that? Computers. Exactly. So we can make the computer do that for us. So here's where it gets crazy. We can write code that tests our code. It's actually really cool. And I think it's really neat that code will test itself. Or code tests other code, but sort of thing. Codeception. Uh, To do that, we have to do a couple things. Okay. One of them, we're going to cheat here. There's ways to put code into different files, right? As you can imagine here, this gets kind of ugly having, 200 something lines of code with 3 different classes that have nothing to do with each other, right? Chair has nothing to do with lotto ticket, which has nothing to do with vehicle. It'd be nice to separate these things, right? And keep them distinct. So all the chair stuff goes over here, all the vehicle stuff goes over here, and all the lotto stuff goes over here, right? And have a nice little bucket for it. And then if we have a nice little bucket for it, when that changes, I can see that in the Git commit history, which is my next favorite part here. So did I show you VS Code's um, repository? So this is the repository for VS Code, not Visual Studio. VS Code is their other tool. Again, Microsoft is bad at naming things as much as I love them. They're terrible at names, but that's okay. So you can go and look at this and we can see, hey, there were 141,150 commits to this tool in the last, I don't even know how long this has been now. Um, sure. But you can go into their source code here and we can go say, hey, I want to look at maybe the typings bit here. Sure. And let's look at the edit context.d.ts. I don't even know what this thing is, but that's fine. I can see it was last changed 10 months ago. So if something all of a sudden doesn't work right with the tool, is it likely that it's the file that changed 10 months ago? Or is it likely to be the file that changed? None of these were changed recently. We'll find a different one here. How about VS? How about editor? 4 hours ago, right? Probably the file that changed 4 hours ago, right? If it just recently broke. So we can keep our history nice and clean by breaking things up into different pieces, right? I don't even like, here's the core bit. Sure, it's got a lot of files here. This is all TypeScript, JavaScript files, best I can tell. Um, and some don't change very often and some do. So if we've broken things up into their nice little neat packages, right, which is one of the benefits of classes, right? I'm going to separate and encapsulate all those details and have one nice little package. I can have one nice little package in a file, and it's separate and distinct. Now, in C++, there's a couple ways to do it here. There's a good way and there's a lazy way. We're going to do it the lazy way. I'll show you the good way. It's a big pain in the butt. There's good reasons to do it. For our purposes, we don't care. When a project gets big enough, then it starts to be important to do it the good way. Nothing we do is big enough for it to matter. Okay, so we'll just be lazy for now and just acknowledge that we're being lazy. So what we do is we make a header file. So header files define classes, and then source files implement the classes. Okay, so we're going to make a new header file. We'll call this one as a .h for header file. It can actually be HPP if you want to be specific for plus plus. Okay, .c and .cpp, C++, .c files. H is the original header files from C. HPP is it really doesn't matter, and the default H anyway, but you might see HPP files somewhere here. We'll call this lotto ticket. Now I have a lotto ticket.h file. Now, if you're using Visual Studio, you get this cool pragma once. It's important later on. If you're using another tool, you have to do it differently. You use a if defined and if n defined. I think they've got it here in Zybooks for us because I can never remember what you have to actually type here because I never do it because I use Visual Studio. So let's look at their separate files bit here. Separate files for classes. Yeah, this if n def, here's the name of the file, and define here, and then end if you don't have Visual Studio with the Pragma once. Okay. The whole reason we do this is essentially when we've gone and used this include here, we said, hey, I want to include IOStream. Mostly what's happening, and it's not exactly 100%, but we can conceptually think it's going and finding this library and copy pasting it here. So everything that's in the IOStream library, that file here, is essentially put into line 2 through whatever. So it makes our program bigger. So and then we include vector. We've taken everything from vector, jammed it in there. So our file gets much larger than it actually looks here because we're pulling them in and essentially copy pasting them in. So if you have lots of different files in your project here, and some of them use Lotto Ticket and some of them don't use Lotto Ticket, but 2 or more use Lotto Ticket, you might copy paste it in there twice or 3 times or 4 times or 5 times or as many times as you're using Lotto Ticket, and that's a big waste. And then things can get confusing. So the if n defined, if it's not defined, if it hasn't already been imported here, please go import it. Here's my definition for it. Okay, it's a little safety thing. Okay? It's not too big of a deal, but Pragma once does the exact same thing, but Visual Studio gives us a shortcut for it here. Okay, so we're going to have our H file here, and we can write our class for Lotto Ticket. Set of curly braces and a semicolon. Now, let me show you the lazy way here. So we take all of Lotto Ticket, and we'll cut it, paste it in here. Okay. Now, when we try and use Lotto Ticket, my program's confused and says, oh, I don't know what this is. It's undefined. I haven't included it yet, right? So the potential fix is include Lotto Ticket H. That's the nice one here. Again, you can type it by hand, but it's nice when the tool does it for you. So if you're importing one of your own header files, you use quotes, not the greater than less than signs. So we're saying, hey, go grab this file, right? And it's lives in the same location as here, so I don't need to give it a path to it. It's in my same project. Life is good. It can go included here. Okay. So now this is the lazy way where I have just a header file, and I'm going to use this because it makes my testing easier. You don't have to follow this way if you do a bunch of extra steps when you make tests, but it's a bunch of extra steps, and no one likes to do that. And again, for our purposes, we don't particularly care. So the next thing that I want to do is I want to make tests. So I want to test my Lotto Ticket class here, separate from just running this main function and looking at my output. Right? I want to write code that the computer will run to test my code. Okay. So to do that, we're finally going to add another project to our solution. Right? A solution is one or more projects. Right? Projects is where we keep code. Okay. So this solution now, I'm going to come to the solution in Solution Explorer. I'm going to say I want to add a new project. Now, For Macland, there's a way to do this, but I don't know how because I don't own a Mac and the college didn't buy me a Mac. Um, there's ways to do it. I'm sure we can Google it here. It'll probably work somewhat similarly. I'd have to imagine because everyone unit tests their code, but that's okay. So what we're going to do is I'm looking for C++ projects. I want to search for test here. And when I search for test projects, I get a native unit test project. Don't use the Google test. It's cool, but again, it's more complicated than we need. This is probably what you have to do in Macland. I don't actually know again, sorry. Um, so the native unit test project, right? C++ unit test using the native Microsoft CPP unit test framework. That's the one we want. Again, we're using Visual Studio. I'm using Visual Studio. That's fine. What do you want to call it? We'd probably give it a good name here. Unit test one. I don't care. It's fine. But if we've got lots of projects with lots of things, you want to name your tests nice here. Unit test one is fine for now. We'll create. So you get a bunch of cool stuff here. So we get, hey, we're going to use this namespace here. We've got a namespace we're including here. And then we've got a test class called unit test one. And then we got a public section with a bunch of test methods, okay, with a name. It's all a bunch of boilerplate stuff here. But what we're going to do in our test code here is we're going to go, did I do something wrong? I just added, I didn't, that's weird. I add in a, no? All right, I think that was there. So the first thing we have to do is go get our lotto ticket code, right? So we want to include, now when I just put in quotes here, it doesn't know where lotto ticket is because it's not in the same folder, right? If we look at this folder structure here, I go show in Explorer here, we'll see I've got my project here. I've got a week 11 classes folder and I've got a unit test one folder, right? Projects generally get their own folder, depending if you check that box or not here. So unit test is looking in the unit test folder. There's no lotto ticket file here for it to import. So what we need to do is we have to tell it, hey, go up a directory, look up a folder, and then look in a folder here. So to do that, you say dot dot here, and then a slash, and then we want our week 11 classes. Now, I'm not typing all of this here. Like as I type a couple letters here, it suggests something. Hang on, week 11, come on, slash. Right, I'm just hitting tab to autocomplete, the same as the rest of the autocomplete works here. And there's a lotto ticket, oops, classes, lotto ticket H. So it says, hey, go up a folder, go into this folder, import this header file. Okay. Now again, the reason we're being lazy putting everything in the header file is so that this copy paste just works. Right. When we look at the split approach here, this doesn't work and it makes me sad, but it's okay. So now I can make lotto tickets, right? So this test method one is we'll do a winning ticket, right? I'm just going to leave test method. It's a convention. It's just named this way. It's fine. It's not going to hurt anything. We'll call this the winning ticket. So what we're going to do when we write tests, there's a convention we can follow. That's a pretty popular convention. A lot of people like it. Not everyone does. But again, if we all follow a convention, it makes life easier for everybody here. So we're going to do this AAA convention here. So we're going to arrange, then we're going to act, and then we're going to assert. Okay. All this means is we're going to arrange, we're going to set up the variables we need. And then when we act is we're going to call the code we're testing. Okay. And then we assert, we're going to check, did we get what we expected? Okay, that's all we do. So each of these sections, we just do something separate here. Right. So as I'm looking through someone's test, if I just want to see the code they're testing, I can go to their act section. Right. There's just ways I can look through pretty easily and organize this stuff here. So set up the variables we need. Well, I need 2 lotto tickets, right? So lotto ticket, ticket 1, given 1, 2, and 3, right? And lotto ticket, winning ticket. We'll just call it a ticket then. Ticket and a winning ticket. Parentheses, 1, 2, and 3, right? 2 different lotto tickets, but with the same set of numbers. They should win, right? Okay. And then we'll actually call the code we're testing. I'm testing the winnings here, right? So ticket dot is winner given the winning ticket. Now that's supposed to return a Boolean though, right? So I need to save this, right? Result. So check, is it a winner or not? Store my result. And then my assert, did we get what we expected here? So this is assert colon colon is true, my result. Did I get what I expected? Is result true? It will test it here, right? This is our unit test. So this will run code and it will check for me, did it do what it's supposed to do or not here? And I can go and I can run my test. So to do that, we don't run the program here. So we go to the test menu here. We go to Test Explorer, and the Test Explorer says, oh, hey, I'm going to go look for tests to run here. We have to build it first, sorry. So let's go build solution, and then it should show the test. There it goes. So it says, hey, I see one test in your unit test project, unit test class, unit test namespace. This is the test winning ticket. Okay, and I can run my test. I'm going to get a nice green check mark or a nice red X, or sad red X actually. So if it passes, I get a green check mark. If it doesn't pass, I get a red X. Right? So I'm going to do another one here. So generally, each test tests one small piece here. We're testing units here. We call the unit test because it tests one unit of code at a time. There's different levels of testing, which is lots of fun. You can get bigger and bigger and bigger. You can do integration testing and system testing and end-to-end testing and user acceptance testing and all sorts of fun stuff. But unit test is one small bit of code at a time. Right? We've done our functional decomposition. We want to test each function at a time, essentially. Right? Make sure that one small piece works. Right? So I'm going to copy paste all of this here, and I'm going to do another test for not winning ticket. So if it's a 1, 2, 4, I should say I'm going to leave it as true for a second here. And let's go run all my tests here, and you'll see it fail. We get a red X. It says, hey, assert failed. Where did it fail? Here at line 42. It didn't work, right? Okay, so is true was not true. So, well, I mean, we expected that because we thought this should be false here. So if I change that to is false and I run my tests, now it should pass. Again, not the most interesting test here, but we're looking at how we write code to test our code. So I don't have to rely on me looking at the output every single time here. Okay. All right, and now they're passing, which is really cool. So I don't know if you guys knew this or not here, but software developers generally make a good amount of money, right? Maybe one of the reasons you wanted to get into the field. Perfectly fair. That's okay. So if you're a company paying software developers to write code for you, right, you want to get a return on your investment, right? You're paying them for their time, their salary, benefit, all these sorts of things here to write software because that software should make your business money or make you more efficient, which saves you money, something like that, right? That's sort of the premise why we have jobs, right? So the longer software works and we keep using it, the more return on investment we get, right? Does that follow? So if they pay us and it takes us 3 months to write a big piece of software and they can use it for 5 years, use it a sixth year, a seventh year, an eighth year, great, that's pretty good, right? They're making money off their investment. Okay. So most of software's life lives in what we'll call this maintenance phase. It's relatively rare, not all the time, but a lot of times software needs to be updated, right? So it's rare that software just is written, done, is never touched again, right? A lot of times it needs updates. We have to change something in it. We have to fix something. We have to go, business says, oh, now I need to do something else with it here. We'll go and modify it. Existing software getting modified. It's being maintained. So maintaining software is where most people spend their time. Right. And it's not bad. It's not a bad gig here. Sometimes the stuff you're working on is kind of old, but that's okay. We're maintaining it and keeping it up and running. So it's a smaller investment than writing brand new software, right? You can pay someone to make a small change rather than start from scratch. Okay. Life is pretty good. So having unit tests and tests in our code makes it easier for us to make changes and feel like we didn't screw it up. Because, hey, a bunch of behavior has been codified. This goes in, this comes out, and we have tests to prove it. So as I go change something to add a new feature or modify something here, if the tests pass, I'm like, okay, good. I did a good job. Didn't break anything. Life is good. Okay. So unit tests help us feel good about our code here. And turns out people like unit tests and we run them all the time. Now, this only took a few seconds here in Test Explorer. It's not terrible here, but can you imagine a larger project with hundreds and hundreds and thousands of unit tests? It might take a little bit of time here, right? And this is a pretty common industry practice here. So because developers don't like wasting time here, we found a way to make someone else's computer run it, right? Should I run the tests on my computer when I can make someone else's computer do it? And I can keep on doing productive things, right? Because they don't want to pay me to sit around and watch my computer for half an hour, right? So we can see there are tests running built into GitHub workflows or Git workflows. So this is called continuous integration testing. It's one of my favorite things here. So as code is integrated into your branches, right, into your source control, that tool can kick off tests. Now, Git itself isn't running tests, so this is a one of the cool features of why people like GitHub, but all sorts of tools will do this feature here. As code gets committed, it will go automatically run tests for me. So again, you have to set this up, you have to configure it, and you write code that does this, that runs the code, that runs the tests, that runs it. It's a whole fun process, don't worry. But you can see, hey, 15 out of 15 tests passed when this was committed. Oh, there's some tests that failed. Only 23 out of 28 passed when this one was committed, right? And you can see every step of the way, oh, they're still running right now here, right? Every time code is committed, you can see the tests here and how many are passing, which is a pretty good feeling, right? Okay, all my tests pass. I feel pretty good about this here. So if you've gotten to the point where you think you have enough tests that give you confidence that nothing broke and it must be working here, you can go to the next step. So if you have continuous integration testing, and depending on your tools and things like that here, you can move to continuous deployment. So as the code is updated and all the tests are passed, the next thing we can do is kick off a process to deploy the code into production. So I can go update my website, I can go update my tool, and now everyone gets a little notification, hey, you have to go download an update or whatever my update process happens to be. I can roll that out. So my buddies who work at Khan Academy, they told me their website, khanacademy.com or .org, I think it's org, they're a nonprofit, is updated dozens of times a day because every time you commit your code and it passes all the tests, it will go and update the website. So it makes developers more productive and faster to get features out into the hands of people who are going to use them. So there's a lot of creative process that happens when you write code here. And if I have to get some idea from somebody and say, oh, okay, you want to go add this feature, add this tool, whatever I'm doing here, I'm changing something on my product, and it takes me a week to work on, and then it has to get tested for a week, and then it takes another week for someone to go and update it somewhere, and then someone has to go look at it, and a week later they tell me it's been like a month since I've done it, and they're going to tell me something about it, give me some feedback, and I'm not going to remember what it was because I've moved on, right? But if the very same day I'm finished with it, I can get it out in their hands, and they can give me feedback like that. I've got the context still, and I am familiar with that piece here. We can get it in the hands of our users and get feedback sooner. So that helps businesses be more productive to have the shorter feedback cycles, right? Because it's hard to get new things in your head and move on to other tasks and bring up old stuff here. So uh, being able to continuously deploy is a huge advantage because we're keeping things up to date, right? And I can get my test my stuff right away, right? It's a lot of fun. So if you have continuous integration testing, you can do continuous deployment. Technically, you can do continuous deployment without continuous integration testing, but no one recommends that. That's probably a bad idea. You want to test your code first. Okay, so all of this to say, if you write a bunch of tests now, we can go and make someone else's computer run them here. Um, you can do this with GitHub Actions. There's a cool thing we can do. It's probably not worth our time. It's just fun to know that you can do it. You can go look it up, how to set it up in GitHub and do it yourself if you so care to. It's not too hard. You have to give it a little configuration file, and then you get your own little green check boxes, and you're happy. You're like, "Am I test pass? Yay!" And you're kind of excited. All right. This was with Lotto Ticket. So the other thing I wanted to show you when we're using separate files here, the other thing we can do, let's do it with a different class here, actually. Let's go add another class here. Let's add a vehicle header. Vehicle. I didn't spell that right at all. Wow, that's terrible. Vehicle. There we go. And let's go move vehicle over. So let's go grab our vehicle class here. Oh, now it doesn't know what strings are. Okay, sure. So we need to include string. Okay, included string and using namespace standard. There we go. Okay. The other thing and the more proper way to write classes here is when we define an H file, all we do is we give it the definitions of the functions. We don't have any implementation of our code. And it looks really crazy, but that's okay. So we're going to, let me actually copy this for a second here. So I'm going to make a matching source file called vehicle.cpp. And I'll put this one in here. And I have to look this up because I never do this because I hate it. Yeah, we include, there we go. So in my H file then, none of these have any code. So I just have a semicolon at the end of my functions here. Uh, semicolons, semicolons. And do I even have my private section? I really don't even remember here. Okay, I do. Okay. So I've defined the attributes and what the functions look like here. This is just their signature, which is their name and return type and parameters, right? Then in the implementation file, the CPP file, I'm going to actually go and flush these out here. So we're going to include vehicle.h here. Now, with this one, we have to go use, so we don't write class, which is the weirdest thing here. So we don't have class here. We don't have public, okay? So all we do is we define these functions and we say, hey, this comes from the vehicle class. Here's the vehicle. Oh my goodness, I can't spell vehicle constructor. So name of the class colon colon here. Name of the class colon colon function. Name of the class colon colon function. Name of the class colon colon function. Okay, all of that, and then we gotta back all this up one here. So I don't think I need the standard because I already have that. I don't need to include string because that came from vehicle H. Okay, so it's as it copy pastes that in, right? I've got the using namespace standard and I've got the include for string already. Okay, now why this is helpful? It's a really long story. The the short of it is it's faster for big projects. Okay. The cool thing that C++ does when we take code and we turn it into an executable is the compiler process. Compilers do a lot of cool magic. In big projects, there's lots of files for them to compile. Okay. So one of the shortcuts that it does is it says, has this file changed or not? And if it hasn't changed, it doesn't have to recompile. It can use the last version that it compiled. So if we have separate CPP files here, it can mark these as previously compiled. I don't need to recompile this for my project. Okay. If we put everything in the H file, it will recompile it every time because that H file is essentially getting copy pasted into the other file. Okay. So if I only have some definitions, it's like, oh, okay, you don't actually have any code here. There's nothing to compile. It goes and finds where they were compiled. It just, here's what it looks like here, and it will go find the matching stuff that's been compiled. Compilers are really cool. There's a whole class on compiler design, and you can take a graduate class on compiler design, and the profs who teach that stuff are really crazy smart. I don't really care how they work. I just like that they do work. But these sorts of things matter for big projects. You don't want it to take 20 minutes to compile because it has to go compile 1,000 different classes, right? If you only touch two, right? If you only touch two, you want it to compile the two you touched. Everything else should be like, oh, I already have it, right? So that's why this is the right way to do things. Now, the downside, if you do it this way, we can't unit test the code without doing a bunch of extra steps. So I don't like doing it, and I will try and avoid it because it just irritates me. So in the real world, you'll do the extra steps here, and it's not a big deal. But from us learning how to do it, it's a pain in the butt, and we don't want to have to do it. Okay, that's okay. It's not the end of the world. All right. So that is classes and unit testing in separate files. Very exciting with separate files here. Unit test. So their unit testing here. Um, it's hey, I'm going to output failed. And I still have to look at the screen and notice if I get a failed message that the output failed, right? Still relies on human error, right? And then I still have like code somewhere, and I don't know. It's doing the same sort of idea, right? It's testing, did I get what I expected? And if I didn't, now I'm outputting a message versus my tool giving me a nice red X showing me stuff failed here. But this is not a very friendly way for us to do it here. Um, right? And you can still make mistakes, right? It's possible to screw up your own tests here, right? Not as likely, but it's possible, right? You can make a mistake in your code, you make a mistake in your test, and you think everything's working, but it's failing incorrectly, right? Sure. So not perfect, but generally any code that's worth writing is worth testing because if you don't care if it works right, why did you write it in the first place, right? If it's garbage, if you don't care if it's garbage, then it wasn't worth writing. Okay. Um, Other cool things we can do are we can do these overloading options here. So let me go to Lotto ticket here. So we'll say, how about instead of passing three numbers here, what if I want to be able to pass a vector of numbers? right? I can do that. So I can make another function with the same name here with a different set of parameters. So I can say, hey, I want a vector of int here for numbers. Okay. Then I can just say, hey, okay, my number one equals numbers dot or at 0. Right? Or maybe I need to check first, like, hey, if my numbers dot size is equal to 3, sure, then we can go do this. Else we're just sad. We haven't got to exceptions yet. That's the whole chapter on the right thing we're supposed to do here. I don't know. Classes shouldn't input and output anything because there's no guarantee that this class will be used in a console-based application. No one could see the message if I use it in a mobile app or a web app, right? Or a graphical user interface application. But all right, so we got number one. We'll do number two. Numbers dot at one. Nubners. My goodness. Number three. Numbers at two. Right. So sure, I can use two different functions here. As long as the parameters are different, C++ will know which one I'm trying to use based on the parameters I give it. Right. So when we go use lotto ticket, right? I could go test that one too if I wanted. Lotto ticket test here. So we'll test. So instead of winning ticket as a 1, 2, 3, we can say, hey, winning ticket. When I give it a set of parentheses, you notice I get a couple options here, right? These ones are a little silly. Don't worry about them. We'll get to them next semester. But here's numbers 1, 2, and 3. Here's, it says error, but that's the vector. I think after we recompile, it'll probably work, but I can give it a vector of numbers if I wanted, right? So I can have vector of int numbers equals 1, 2, and 3. Because we didn't include vector. That's why. I go include vector. Now I can give it numbers. And I can use the other constructor. Really? Oh, this is the namespace, right? Using namespace. Standard. That it? Standard? Okay. Now it's all happy with me here. Now we should see, yeah, vector of int numbers. Okay. Now again, we can run our tests using a different constructor. Life is good here. It should pass. We'll see. It's possible I screwed up. Oh goodness. Build errors. Wow. It's real mad about vector here. Include vector. Namespace standard. It looked like it lit up okay. That's weird. Try it now. Let's throw that in everywhere, I guess. All right. It's running. Hey, okay, now it ran. Life is good. So we can use a different constructor. So not only can you do that with constructors, you can do it with different functions as well. So your functions can have different arguments. Now with this one is not very interesting. Let's see. Vehicle's probably not very interesting. Those are all strings. What about chair? Do we have anything fun with chair? Let's see. Chair. Yeah. What if we wanted to have this as maybe a double, right? One is an int, one is a double. We could do that, right? So we could have a void set height in centimeters. I guess I'll just copy paste. That was a bad idea. Centimeters, given a double height in centimeters. Sure. So I can give it an int or a double. Now, if you give me a double, but I can only store integers, I'm going to like truncate it. I'm going to lose some precision. It's probably not the end of the world here. Um, and it even lets me set it. That's funny. Set an int to the double. Sure. But now I've made this function a little bit easier for whoever wants to use my class because they have different options for what they want to give me. Right? Rather than making the person use my class have to do all the conversions, I can handle how I want to do the conversions in my class. It's just an option. You don't have to do these overloaded methods, functions, but you can if you want to. Right? Or if it makes sense to have different sets here. So did we do a constructor? We didn't do a constructor for chair. So maybe we want to have a different constructor for chair that defaults some values. Right? It'd be nice, like, oh, hey, if you don't tell me if you have arms or not, I'll assume you don't. If you don't know how many wheels you have, I'll assume it's 4. Right? Or that should be legs, right? Not wheels. I named that badly, right? I guess all of our chairs have wheels, but probably some chairs have legs, not wheels. So you can overload them, right? So we got options for overloading our functions here. For um, the operator overloading. If you want here, you can say, hey, how do I define adding two classes together here? This doesn't make sense for most classes, but occasionally for a class, it makes sense that this instance plus this instance gives you something, right? Depends on what we're working on. So in this case, they're doing time here. You can add two times together, and we just add their hours and minutes and seconds together. Sure. Uh, you can do those for operator overloading. Um, so you can do addition, you can do subtraction, you can do multiplication, you can even do greater than and less than. Right? We can say, hey, I want to say, is this one bigger than another one here? Yeah, here's the list of overloadable operators. How exciting. Here, any of your operators you can overload. That's a lot of them. But again, if it makes sense for your class to do that, you can go and define what that looks like. And that's something you'll do next semester as well. Let's see. Static data members and functions. So far what we've looked at, when I say this is a private attribute, it means every instance of chair has its own set of these, right? Because these are instance attributes, right? So every chair gets its own unique set of these values. The opposite of that is static. So static means it is defined once at the class level, and all instances of the class share that value. Right? So depending on what we're writing, this can be helpful here. So something like lotto ticket here, let's go to our lotto ticket class here. It might be nice to know the cost of a lotto ticket. And depending on what lotto you're playing, again, I know it's not always the case here, but usually the same lotto ticket costs the same amount. Right? So defining it once at the class level makes sense because I don't need to store it 1,000 times in memory if people buy 1,000 tickets. Right? I only need to store it one time because every ticket costs $1. That sort of thing here. So we can define attributes as static here. Why is it not like lotto ticket? Uninitialized. Oh, because I have the if else here. That's why. That's fine. So to do that, we're going to define a static attribute. So it's a static data member. So we say, hey, it's a static something here with the static keyword. Now, it's probably a public attribute. It could be private, but it's more useful. It's a public attribute here. So I can make a static constant int ticket price. Now, I want to mark this as constant because I don't want it to change. Sorry? So static means it will exist once at the class level. So not every instance of lotto ticket will get its own copy of ticket price. It is just defined once in memory. So I could have 10,000 tickets in memory, but ticket price only exists once. So I haven't wasted, 4,000 bytes. So it's a good practice if there's some value that doesn't change that belongs to the class. The other example here they give you is like the next ID. So every time you make one, we can increment this value. So inside of its code, it just increases the next ID by one, increases the ID by one, because all the classes, all the instances have access to it, and they can modify the value. So it says, okay, I'm going to make a store. It gets an ID, and then I'll add one to it. I'll make a store, add one. So it's the way to it counts itself how many of these I've made here. It's kind of handy that way. Uh, most of the time, you don't want your code doing this though, so it's not all that useful. But this is defined once and stored once at the class level, not per instance. All right, so that's static stuff. I think that covers it for classes here. Yeah, I think that's pretty good. Yep, cool. Oh, this is the inline member function. We define them there. That's inline. We've defined it inline like in the H file here rather than the separate files. All right. We can get to pointers Wednesday here. That should be okay. We want to talk about the final project. Okay. So let's get to the final project here. Make a new GitHub repo for you here. 50 all final project. Go private. So one of the cool things GitHub Classrooms can do, if I so care to, it could add, you know how we did unit tests? It can do a very similar thing with auto grading. So you could say, if this input goes in, this input should come out, or this output should it'll come out. But if this goes in, this comes out. Right? You can set that up with a file here to define that. The problem is it has to be very specific and everyone has to take the exact same input at the exact same order and the exact same output letter for letter, case for case. That's a big pain in the butt. But you can do that same sort of thing here, and that it's that common that like, oh, you can use that same framework to do auto grading tests, and you could say, hey, you got 10 out of 10 points, like the same way your Zybooks does with Zylabs. Hey, I ran all these different inputs, I got these outputs, same idea, right? Um, that's all kind of based on unit tests. All right, hit the link here. Final project, very exciting here. You guys like games, right?
Yeah.
All right, good. And this will be due. Oh my goodness, was it the 15th? And what time were we? Were we 12:30? We can change it if we need to here. So for 40 points for this one here. All right, please submit the URL of your repository. Self-assessment, assessment using the rubric. All right, and forgive me a shameless copy paste here. Oh, and look at that. Oh, yeah, and screenshots of it running in the README as well. So for this final project, for a couple reasons here, you'll have to have at least 10 commits of working runnable code over 10 separate days to get a score. Okay, it's good for you because you're going to have to start early. It's good for me because it's really hard to copy paste something from ChatGPT and cut it into 10 chunks that work. I'm just going to be honest, right? That's one of the reasons I do this. And it makes you start early, right? It's not just for that. It's a good to force people to start early here. So we've got close to a month here. So every third day or so, get a commit in, right? This should not be unreasonable. Is that okay? All right. So 10 commits, 10 separate days, and working code. So every time we make a commit here, we're going to add a screenshot of it running to the README file. So hey, commit number one, here's what runs right now. Commit number two, here's what runs right now. Again, copy pasting working code from ChatGPT is really hard to do. To take a tenth of it and a tenth of it and a tenth of it, and I've seen like when I used to do this, and I didn't require working code. I just got here's 50 lines, here's 50 lines, and like they even like did the middle of a function because they were super lazy how they copy pasted. Like you didn't commit half of a function and finish it. And they're like, oh yeah, I figured I'd finish the function later. It's like, come on, am I stupid? Do I have stupid written in my face? I guess I have a Snorlax hat on, but I'm not stupid, right? All right. So 10, at least 10 commits. More is okay here. 10 separate days, working code. Right? The idea we're going to take it chunk by chunk by chunk. Let's just get it up and running here with some menu, right? It doesn't have to do anything when I click the options here, right? Okay, now I've added this function here. Now you can do this option. Okay, now you can do this next thing, right? We're going to break it up into small pieces here. Okay, does that make sense? All right. If you're working with a partner, that's 5 each, right? Or 7 and 3, something like that, right? So it doesn't need to be 10 per person if you're working with a partner. Okay. Um, Let me know your GitHub usernames and I can set up shared access if you'd like to work with a partner. Right? You don't have to, it's up to you. You'll get into forced group projects eventually. You'll love it. It's actually good for you because working as a developer without having a team is really sad and lonely here. And working with another person makes you better and makes the product better. Um, and if you get to pick your partners, even better. It kind of sucks to get forced to work with people, but that is sort of how the real world works. You get hired for a team and you didn't pick your team. So, both ways are good. So it's a basic version of Monopoly here. Not every single feature of Monopoly. Have you guys played Monopoly before? If you have not, you want to go play it. Okay, you can play it for free online somewhere, I'm sure. Just Google it here. I can bring in the board game at some point here, but it takes a little bit long to play the game here. So that's why ours is a basic version here. So our 10 by 10 board, 40 spaces. Okay. We don't need to have the chance and community chest. They're just blank spaces here because pulling a card and picking what happens when you get the card is complicated here. It's a feature we don't need to have. That's okay. All right. So what we're going to do when we start our program, we're going to ask the user, do you want to start a new game or load a game? So one of the things you should save for later is saving and loading, right? Don't do that at the first thing, right? That's a feature you can add in later, right? One of your later commits, right? That makes sense? Okay. For a new game, ask how many players, 2 to 8 players. 2 players, 3 players, 4, any sort of number of players is fine. Each player starts with $1,500 and on the go space, the start space, right? So if you have 40 spaces, you probably have a vector, right, of spaces, these sort of things here. We've got options, right? And then things to add in later, like the go to jail space. Space number 30, I think, is go to jail. You go to space 10, the jail space. Okay. Um, you go to jail for rolling doubles 3 times in a row. Usually, when you roll doubles, you get to go another time. You get an extra turn. If you've done it 3 times in a row, though, you don't get your third turn. You just go right to jail. Okay. So add that in later, right? That's a nice feature to add later. Doesn't have to happen right away. Okay. So all these sorts of things we can think about. Okay, I can get a basic version working, then I can add more interesting stuff. Okay. Um, for when you go to jail, just have them pay $50 and get out. It's more complicated to make sure they have to roll doubles to get out of jail. So just when you go to jail, you pay $50. That's probably the easy way to tackle that. Okay. Um, classes we should use. Now, you should use classes for this. You don't necessarily have to, but it's going to make life a whole lot harder because classes let us encapsulate all the details and talk about these things as nouns, right? A player, it's pretty easy. They have a name or a number, player one, player two, player three, player four. Feel free to use numbers, or you can have by name, any way you want. That's okay, right? How much money they have and what space they're on, or what index they're on in the vector, right? Hey, I'm space 0. I'm at start. I'm at go. I'm at space 27, right? Is that Marvin Gardens, I think, 27? Or is that utilities? Might be waterworks. Um, that's okay, right? And then properties, right? The spaces on the board, right? They have a name. This is what the space is. They have the purchase price. They have a rent amount. So when you land on the property, if you don't own it, you have to pay someone rent, right? Okay. So whoever owns it, right? You pay that amount of rent. We're not going to worry about building houses, right? Worry about building hotels. Don't worry about doubling rent if you own the whole thing. Again, this is just a basic version here. So it's going to be really hard to lose because every time you pass go, you get $200, and it's hard to lose $200. It's just basic rent. Okay, that's okay. Yeah. So each property has a different rent number, but it'll stay the same rent, right? Oh, there's a list online. Yeah. Yeah. If you want to come up with your own property names, that's cool too. You don't have to use the canonical ones, or you pick your favorite edition. That's fun too. Yeah.
10 different classes or 10 different functions? Like, how do you want us to space?
The commits are just you've got a commit of this is what it's working so far, right? It starts as do you want a new game, load game. Load game doesn't work. New game says 2 to 8 players. Sure, that's day one.
So if I have a broken code that just combines.
You want something that works and runs, like that you can test that little bit here, right? So all these little pieces here, maybe you don't charge rent. Every time you land on the property, it just says you landed on this space. We haven't figured out how rent works yet. That's something we could add in later, right? So lots of ways we can break this up into small pieces here. So yeah, make your list of properties, have your list of players, figure out saving and loading later. That's a whole other thing, right? When we looked at files, we have to write lines to files and figure out what's in there. So the easy way to do it is probably tell the first line is like how many players, and then you know how many players to go read, right? And then you know there's always 40 properties because properties need to know who owns them, right? Or maybe the player has the list of properties. There's ways you can store that information, however you want to tackle that. A couple options there. Okay, that makes sense. Cool. So that's what we're doing for our final project. Again, just a pretty basic version here. We don't need all the fancy features, but it should be enough to do a small little project off of this here. The 15th at 12:30. Let me just double check that's the right time. Yeah.
And for the dice, wanted to know
So you roll 2 6-sided dice. So no, 2 6-sided dice, right? If you roll 2 6-sided dice, you're much more likely to get a 7, right? A sixth of the time you'll get a 7, and it's much like a 136 you'll get a 2, 136 you'll get a 12, and you get a nice little distribution curve there. Um, yeah, don't get me started on dice. Yeah, 12:15. Oh, 11:30 a.m. So 11:30. We'll fix that for you. We'll probably be in this room again. They don't publish the schedule till the week before, so if you see it there, that's fine. And do 12:30 or 11:30. All right, cool. We got 15 minutes, so we should talk about pointers then, because you probably will have a lab on pointers. Because I've not yet talked to Dr. So and so. Really should remember his name. I'm sorry, Saeed, Dr. Saeed, to tell him I didn't do anything Wednesday. I'm behind because I forgot. All right, but we'll talk about pointers. It goes pretty quick. We start with a new project. At least the basic stuff here. So this will be, oops, I wanted console. There we go. Week 12 pointers. Yeah, so instead of taking a final exam, you'll get up and run your code. Show us you can play a game, save a game, load a game. Takes maybe 5 minutes. If you like to talk a lot, a whole 5 minutes, usually three.
So people are like looking to together.
Yeah, yeah, yeah. If you work with a partner, you present together. Yep. So I can either you can plug in if you got an HDMI port on your laptop. I've got a USB-C adapter that usually works, or I can even just clone your code from GitHub and hit run from my laptop. We got a couple ways we can make it run, but that way everyone gets to show off the project they ran. I might have a question or two about your code, right? Um, Again, you should be able to explain what's happening in your code. I think that's a pretty fair requirement. So if you want to get one small piece here and there, a specific focused area from a tool, that's great, right? Hey, how do I go do this part? I'm okay with that. Cite your source, right? But English paper rules apply. The bulk of the work has to be yours, right? And if you can't tell me what the code is doing, it's not going to fly, right? You can't cite some work and not know what it's doing. That's incredibly dangerous when it comes to writing code in the real world because you're likely to screw something up if you don't know what it's doing, right? Don't trust the machines, please, right? Be smarter than that. Yeah.
No.
Oh, okay. But question. Uh, cool. So pointers using namespace standard. Now pointers are fun. They are the bane of C++ here, but it's okay. We'll make them work. So far, all of our variables have been a certain type. And we said, hey, this is an integer for number, right? We set a value to it. Right? What's different with pointers is we create a variable, and that variable is just the memory address of where the actual thing is in memory. So it's a pointer to where it lives in memory. It's a very weird distinction here, but it's okay. We'll dive deeper into it next semester, but we want to start talking about. So I say an int star. So star is the keyword for pointer here. This would be my number pointer. Okay, number pointer. So the value of number pointer is a memory address of where that integer is stored in memory. Right? The value of number here is the number 42. Right? The, the value of number pointer is the memory address where the number is stored, where int is stored. Okay. To set the value of number pointer here, number pointer, I don't want to say equals 42 here. It's not even going to let me do that. It's going to say, oops, there we go, number pointer. Says value of number pointer is the okay, sorry, that was my comment there. This one here, a value of type int cannot be assigned to an entity of type int star. Right? You can't assign an integer to an integer pointer. It's expecting a memory address here. So what we need to do is we will dereference our pointer and say, hey, the thing that it's pointed at, set the value to. Right? So we put a star in front of it here. Say, take the place it's looking at, take the place it's pointing at here, assign it the value of 42. Okay? And then I can see out number pointer, and I'll put a number pointer in here. Okay, so what do you think when I output number pointer, what am I going to get?
Memory.
The memory address. Yeah, not 42, because it's the value's memory address. Oh, goodness, build errors. Sorry, this one. Is that working? Goodness. Uninitialize. Sorry. Equals new int pointer. No? Why am I failing here? Wow, I need to go look at Zybooks, I guess. I hate pointers. That should have worked. Sorry. No, I don't want that one. I just want a single pointer. Why am I so dumb? Number pointer. Um, int pointer? Oh my goodness. I have to Google it here. I'm so sorry. C++ int pointer. I want to make a new one. Okay, sure. We can do that. So when I set the number pointer here, let me go, I'll leave that line alone for a second here. It's expecting not an integer, it's expecting an integer pointer or the memory address. To give it a memory address, I have an integer in memory. I don't know what its address is, I just know its value. There's another fun character we're going to use is the ampersand. So it means the address of. So it's the address of number. So my number pointer points at the address of number. Right? So that's the ampersand sign. Stored address of. Okay. So then if I wanted to change number pointer, again, I still have to do that dereferencing thing. Number pointer equals 77. Okay, I can go change the value of it if I wanted here from 42 to 77. And if I put this in debug mode and run it for a second, we're going to see numbers 42. Number pointer is x00. This is some hexadecimal memory address here. The value is 42. So if I'm about to change the value that number pointer is pointed at to 77, right, it also changes number because number was stored at that location in memory. So I have a pointer to where this thing is stored. So I really have number points at this and number pointer points at it, right? I've got two things pointing to the same location here. But when I output my number pointer, right, we get memory address garbage, not a very useful variable. It's not super helpful here. Right? We get the address of it. Okay, so that's a single pointer, not very helpful yet. The next cool thing we can do with pointers is I can have dynamic arrays. We can make arrays kind of work almost like a vector, but they're still not resizable here. But I can make one without knowing the size ahead of time. Hooray, finally we can do something fun. So I can cout enter a number of ints to enter, and I can have a int number of ints. Sure, we'll just say numbers. Why not? And I can see it on numbers. Now I can make a pointer to an integer as an array in dynamic memory. It's a lot of fun stuff happening there. So everything we've done so far with arrays, when we compile it ahead of time, we know how much memory we need, and all of that memory is allocated on the stack. Don't worry too much about it here, but it's a smaller space. We don't have as much memory on the stack to work with. If you want to get at the rest of the computer's memory, that's known as the heap here, we have to use dynamic memory. So as the program's running, then it will dynamically ask, hey, operating system, please give me a hunk of memory. We don't know what it is before we run here, so I can't allocate it on the stack from when my program starts. The idea when I hit start for my program, C++ goes out to the operating system and says, hey, I need 59 bytes of memory to store my entire program. Right? I know ahead of time, and they can allocate everything ahead of time on the stack here that my program needs to run. If we need more space than that, or if we need to know while it's running, we can use the heap memory, where it's everything else we can store, which is really fun. So I can go out and say, okay, now I have an integer array, or an integer pointer. We're going to call this number, I don't know, dynamic array equals a new int pointer, or no, a new int array size of numbers here. So I have a pointer here to an integer, but I'm getting this number of integers space in memory allocated on the heap here. So allocates numbers worth of int of memory on the heap. Okay. Now, the pointer itself is still just the first location where it starts. So all that same arithmetic, like when we looked at, hey, we start at index 0, we go to index 1, we go to index 2, you can jump around here because it's that memory address plus whatever index you want times the size. Same thing happens, right? Our pointer is used as the starting address, and that's why it stores an address. Here's where this thing starts in memory here. So I can then go through, I don't know, for int value Our index is 0, index is less than numbers, index plus plus. You can see out, enter number, index, and I don't know, colon, and then we can see in a value to my dynamic array, index of index, dynamic array, index of index. Enter the next number, enter the next number, enter the next number here. So however many they told me here, I can start adding them into that location. Right? I've sized it ahead of time, but I don't know what it is when it's running here. And then for, I don't know, value in dynamic array, dynamic array. Is that not, did I spell it wrong again? Oh, I can't loop through it that way, shoot. It's 0, that's less than numbers. Now, you don't know the size of it, though. You can't ask it size, so vectors are still better here. Um, but that's okay. We can see out the dynamic array at the index. And that line.
Function of the dynamic.
Oh,
That's why it keeps.
oh, because I, goodness gracious, dynamic. Yeah, okay, there we go. So if I spell it right the first time, did I not hit enter? Really? Dynamic array, apply, apply. All right, whatever. That's fine. It didn't work. It's being cranky with me. Oh, that's right. We don't need a breakpoint. We'll continue. All right, so we enter 5 numbers here. So 1, 2, 3, 4, and 5. 1, 2, 3, 4, 5. Very exciting. Now, if we put a breakpoint in here and we look at it here, 3, 4, and 5. My numbers dynamic array here, I can't see the values of it. I only see the value of the first number. So it even sucks for debugging because you can't see the contents like you can a vector. In a vector, you can open up and see all the values here. Kind of sucks. Okay. But silly things you can do with this now, instead of this kind of loop here, I can say, hey, I want an int pointer where the current address starts at dynamic array. Dynamic, oh my goodness. Sure. Right. And now I can go through and print out just that value here, right? So if I wanted to see out my current address, dereferenced, right? I want the value there, not the memory address there, right? I can get out the value there. So this will give me 1. Then the next thing you can do, because these things are silly here, is you can add to it. I can say, hey, take my current address plus plus. This adds the size of 1 integer to the memory address, right? So when I add to this address here, it adds the 4 bytes, right? And we'll move it on so that I can see out the next one. And I can add some and add some and add some, right? Keep going and keep going here. We'll just copy paste for a little bit here. So that's 2, 3, 4, 5, right? I think I got them all. 1, 2, 3, 4, 5, right? If I do it again though, what am I going to get at the 6th address? There's nothing there, right? Am I going to get hot garbage? If you're a trash panda, you're excited for hot garbage. Garbage. So again, you can still do bad things with it, just like we could with arrays here. Gotta be a little bit careful. There's some cool things we can do to find the starts and the ends and do this sort of arithmetic. Um, it's okay. We'll get to all that fun stuff later here. But we got most of that in our pointer. So this is dynamic arrays, dynamically allocated arrays. Now the other thing we have to do is you have to delete the memory when we're done. If we don't, so when the program ends, C++ gives the memory back to our computer. But if our program is a long-running program and we don't tell it to delete here, we're hanging on to that memory and not giving back to the operating system, bad stuff happens. So what we can do real quick here for fun, so we'll say for int, I don't know, times it's 0, times is less than, we'll do like million, is that a million, 100,000? I don't know, we'll do a bunch here. Times plus plus. We'll go and allocate a new array here. So we'll say integer pointer values is a new int array. Let's do size, I don't know, like 10,000 here. right? And I don't delete it here. I'm going to be taking 40,000 bytes, 40,000 bytes, 40,000 bytes, 40,000 bytes a bunch of times here, right? We do if times modulus 1,000 equals 0, cout times. I'm going to put a breakpoint here. So while it's running in debug mode, sorry, we'll just take like 30 seconds here to show you. Your program has, or Visual Studio has this cool diagnostic tools that tells you how much memory it's using. So as I continue on here, we can see I'm now using 2 gigabytes of memory here. Now I'm using 2.2 gigabytes of memory here. And if you look at your task manager, it should show some process using a whole bunch of memory here. Let's see if I did it right. Yeah, I guess it's not exactly 2 gig, but there it goes. Yeah, my pointers, here it is, 2 gig of memory. I never deleted it here, so C++ didn't give it back to my operating system. So eventually it will crash, either my computer or the program, when it runs out of memory, right? Just keep on going on this here, take out the breakpoint and continue. 6, 7, 8, 9, 10, 11, 12, 12 and a half. Uh-oh, 12.5. Did it stabilize? It might have stabilized. All right. I didn't make my computer crash. That's probably okay to not make my computer crash. But oh, there it goes. Oh no, that's because we stopped it. Sorry. But bad stuff happens. That's called a memory leak here. All right. Thanks. I'll see you folks on Wednesday.